All right, so now we're going to do practice E, and we're going to do number 2. So before I even read the problem of doing projectile motion, I'm going to write my given, and I'm going to write my x and my y given. Why am I doing that? Because my horizontal and vertical motion are independent. So I know ax is 0 and g is negative 9.8 meters per second squared. Every single problem. So it says a projectile is fired with a velocity of 196 meters per second at an angle of 60 degrees. So now I'm going to draw my picture. This VI is equal to 196. And it's going to go like this. And this angle here is 60 degrees. Now don't draw like a triangle. I saw some people doing that. So that's my picture, because the picture is going to help me. So before I even read the rest of the problem, I know I want to find VIX and VIY, because I'm given the initial velocity and the angle. So what I'll do is, since I want to find the horizontal and vertical component of this vector, I'm going to draw it on the side. So this VI is equal to 196. Now, the component direction are very important. This is where I start. This is where I end up. So first I'm going to go horizontal. This is VIX. From the head of this vector, I'm going to do the tail of the other, because the components have to be perpendicular, and this is VIY. And this is 60 degrees. Now, do I use sine, cosine, or tangent? Well, I see VIX is adjacent to the given angle, and cosine of theta is adjacent over hypotenuse. So I know that VIX is equal to VI cosine of theta. So VIX is equal to 196 cosine of 60 degrees. Now, we need to know how to do it on the calculator. So on the calculator, what I'm going to do is I'm going to press 60 cosine times 196 equals, and it comes out to be 98. So this is going to be 98 meters per second. VIY is equal to 196 sine of 60 degrees. Why is it sine? VIY is opposite the 60-degree angle, and sine of theta is opposite over hypotenuse. So this comes out to be 170 meters per second. And on my calculator, 60 sine times 196 equals, and it says 169.7, so I put 170. So that's part A. Now, part B says, what's the total time in the air? So the total time is from here where I start to here where I end. I'm going to show you 2 ways to do it. The first way, I know that from here to here, I know that y is 0 for the total time. So I know that if I use the equation y is VIYT plus 1/2 GT squared, this would be 0, and then I could substitute in my values, like VIY is 170T plus 1/2 negative 9.8 T squared. The problem with this is, and it's not really a problem, I have a t and a t squared. So in order to solve that, I would have to use the quadratic equation. But you know what? I don't feel like using the quadratic equation. So I'm going to say, is there another way? Because remember, I'm trying to solve for y. So let me show you something. In this diagram, this is my initial velocity. We do not take air resistance into consideration in this class. So this is my initial, this is my final velocity like this. Now I'm going to draw a picture and I'm going to show you the difference between my initial and final velocity. So my final velocity is going to be like this. This is VF, it's also 196. But when I look at my components, this is where I start. So this is VFY. From the head of the other vector, I do the tail of the other. This is VFX. Now remember that there's no horizontal acceleration. So we know that the horizontal component of the velocity is constant. So we know that VFX is equal to VIX, and that's a constant. Now if we look at this and this, we see that this VIY points up and this VFY points down. So those vectors are equal in magnitude but opposite in direction. So VIY was 170 meters per second and VFY is negative 170 meters per second. So now when I want to find my time, I know that I know VIY, I know VFY, I know G, and I want to find T. So I have my equation VFY is equal to VIY plus GT. So when I rearrange the equation, I have VFY minus VIY over G is equal to T. Now, people make mistakes when they do it this way. Why do they make a mistake? Because they're not consistent with their sign convention, and they're not careful putting their numbers in. So watch what I do here. VFY is negative 170 meters per second, minus VIY, which is positive 170 meters per second, divided by negative 9.8 meters per second squared. Now when I do this, the negatives in the numerator cancel with the negative in the denominator, but you see how negative 170 plus negative 170, because you're subtracting it, okay? So my time comes out to be 34.7 seconds. Now, here's your choice. If I want to find the time, I can use this equation, but then I'm going to have to use the quadratic, or I can do this way. Now this only works when this is on this level surface like this, as far as the VFY being equal to the VIY. Okay, as far as equal in magnitude and opposite direction. Okay, now let's look at part C. Now part C is easy because we've already done this. We know X is equal to VIXT, and remember our original equation was 1/2 AXT squared, but AX is always 0, so that whole last term disappears. So this just becomes 98 meters per second times 34.7 seconds, and that's about 3,400 meters. The last part says to find the maximum height. So let's look at our picture. the maximum height is right here. So this is my maximum height, y. Remember, this is our frame of reference. We're using our standard Cartesian sign convention that up and to the right is positive. So this would be a positive value. Okay. So now I'm going to show you two ways to do this. This maximum height occurs in half the time. Okay. So what I can do is I can take my total time from here to here and use half the time. So to do it that way, I could say y is equal to VIYT plus 1/2 GT squared, but I can use half the time. So if I do that, I would get y is equal to 170 times 17.35, because that's half of my time, plus 1/2 negative 9.8 times 17.35 squared. Now, on these calculators that aren't graphing, when you try to use parentheses, sometimes you make a mistake. So guess what? Write another line. This way you're less likely to make a mistake. So go ahead and do the math here, and then do the math here and subtract it. So when you do that, this comes out to be 1475 meters. So that's one way to do it. Whoops. But I'm going to show you another way to do it. Okay? In physics, many times there's more than one way to do a problem. Which is the way that you should do it? You should do it the way that you best understand it. And sometimes you might do it one way, and sometimes you might do it another way. Okay, so now, this I have to go back to the picture for. So they want me to find this y here. Now watch what happens. I'm going to cover this with my hand. All right? At this is where I want to find y. So right here, this is VFY. So at this point, at the top, VFY, so at this point, VFY is 0. Right? We already talked about that. So, because right there, VFY is 0, let's go back down. I have VFY, which I know is 0. I know VIY. I have G, and I want to find y. So now I can use the equation VFY squared is equal to VIY squared plus 2GY. So I'm going to rearrange the equation to solve for the unknown in terms of the known. So VFY squared minus VIY squared over 2G is equal to y. Now this is 0, so let me get rid of that. So I'm basically going to have negative 170 meters per second squared divided by 2 times negative 9.8 meters per second squared. Now remember, we can always carry our units through and cancel them to check our work. So when I do it this way, I also get 1475 meters. So you see in two parts of this problem, I can find something two different ways. But you do it the best way that you understand it.